Hi, everyone. Thanks for joining this evening or whatever the time is there in your time zone. Today, we will be talking about unveiling the cosmos, and I would try to give you your own guide to exploring astronomy by giving you a bit of glimpse about my journey. So, what I'll be presenting will be in three parts. In the first part, I'll talk about my journey as to how I got into this PhD program and how and what I'm doing where I am. In the second part, I'll specifically talk about my projects in the PhD. I'll give you a bit of glimpse about what I have been doing in the two projects that I have been assigned. And then in the third part, I'll talk to you about how even like right now you can get involved into being an astronomer by yourself. So we can start right away. So my journey into astronomy started doing something like what you guys might already be doing at the time. So it started by looking at a lot of launches by ISRO, by NASA, of the missions like Mars Mom mission, ExoMars, and etc. So I used to just sit behind my TV screen and just wait for these missions to be launched, for the satellite to be deployed, and things like that. This is when I realized, along with doing physics in my 12th standard, that physics is one subject that really makes sense to me as a lens for exploring the world around me. And I tried to then carry this passion forward by pursuing my bachelor's in Delhi University. I did it from Deen Dayal Upadhyaya College. And there, when I was doing my bachelor's, I realized that physics has a lot of elements onto it. Especially one of the elements of the physics is to make the people aware of how beautiful the world is through the lens of physics and through the lens of astronomy, particularly in my case. So I was lucky enough to find like a couple students who carried the same passion, and then we founded um, the first astronomy society of Deen Dayal Upadhyaya College, and it was called Spacer Nova. And it was called Spacer Nova at that time. Now the name has changed. But in the panel number 3 here, you can see one of the sessions that we had organized in Nehru Planetarium. So being a part of this society, interacting with a lot of people, that's when I actually realized that how people perceive astronomy in terms of the youngsters and in terms of the general people when you tell them that, oh yeah, I'm interested in this particular subject. For the kids of my age at that time, like 18, 19 years old, when you talk them about studying astronomy, most of the people are interested in doing the subject. Most of the people are interested in doing the physics. But when it comes to astronomy, they don't really know about like a clear path to, what is the clear path that they can take to excel in astronomy or to build this career in astronomy. And not even that, there were not even robust resources which were available that can be understood by undergrad level students, by 12th class students, so that they can start building their foundation really, really slowly to carry their passion into astrophysics as a career. That is what actually made me build my blogging site called Yugen Theory, which has been introduced before as well. So this Yugen Theory, it is a blog site. You can see the link of this blog site over here as well. Check it out in your free time. It's absolutely free. And there, while reading the papers during my undergrad and during mostly my undergrad and during my master's, that's where I read the papers and I tried to see if I can simplify whatever my understanding is it with that paper and with that astrophysics book into something that can be understood by the common people, so that we can break this kind of mindset and this kind of analogy that astrophysics is always very difficult and is something that no one can really understand. Because I think that astrophysics is something that provides you a new way of looking at the world around you. And it is so beautiful to be able to understand it, to be able to understand all the elements, all the different elements of the world around you, what you are made up of, what your future is going to be, and how the things work around you. I think astrophysics answered all of these questions. So with this passion in my mind, I started this blogging site, and fortunately it has been running really, really well. And with this blogging site, I was not able to only enhance my knowledge in the physics, I was also able to get selected into the first summer school that I applied for, and it is the inter-university. It was organized by the Inter-University Center for Astronomy and Astrophysics. Joining that summer school was really, really like a turning point into my journey in astronomy, in a sense that this summer school was really focused on the core basics of astronomy. So there I learned the thermodynamic principles, the electromagnetism, the Kepler laws, and all the basic laws of physics and astrophysics, which were really needed for me to see if I'm really interested in the subject, to pursue it as a career in my future, and to also see that this is something that I really resonate with. So the answer for those questions turned out to be yes. After I joined the summer school, and it really turned out to be very beautiful in enhancing my knowledge, which later led me to going to my professor. And because in Delhi University back then, I think it would have changed now, but back then it was a 3-year bachelor program, and there was like no research here. But I really wanted to do something of research during my bachelor's in during my bachelor. So then I approached my university professor and I asked him, "Do you have any unofficial research opportunities under you? I mean, it doesn't need to be put anywhere, but I just want to be under you and want to read some papers, and I want to do the things like maybe similar to the way a researcher would do." So then he directed me. Dr. Deepak Jain, he directed me to this wonderful series of papers on curved spaces and cosmology by Friedman. So there I first learned about the Friedman equations, the expansion of space, and there were some questions in the paper. I tried to solve them, and then I realized that this is something that I can actually do. I'm interested in, and I would like to do it a bit ahead into my future as well. Then I was thinking about joining my master's program and trying to gain more experience into astronomy, and now a bit on the professional side of the field as well. So I was trying to see how can I get working, like how can I get a bit of experience of working with telescope and working with the real data to see how it is really like. That's when I actually connected with Sovanacharya sir and the SA Citizen Science Group. And there I joined the Zooniverse for the first time, and I learned about a lot of projects under disk detective. So there it was about detecting the disk around the dying stars. I was involved in one of the projects related to supernovae, in which we collaboratively ended up discovering one supernova as well. One of the projects was related to asteroids, one was related to exoplanets, and there are a plethora of the projects that you can actually do in Zooniverse and get started with. And then there were some citizen science projects that I did under NASA as well. So doing all of this, I was really sure that physics is something that I really like, and as something that I can really do professionally in future as well. And that's when I decided to do my master's in astronomy and astrophysics in KU Leuven, Belgium. So I worked on a lot of projects, a lot of different projects in my master's, and now it was much more focused on astrophysics rather than general physics part of the things. So I did a lot of things related to computational research, because this is really the basics of doing astronomy, learning about machine learning, learning about linear regression and things like that. Then I worked a lot on simulations, which I am currently doing right now as well, in which I was working on the simulations with solar atmosphere using some different softwares like MPI Amarvak, the one that I mentioned. In addition to the simulations and computational research, I was also working on analyzing the observational data from spectrographs around the world, and also analyzing the data of the Milky Way and the satellite galaxies of the Milky Way in general. I continued doing my Yugen theory blog site, which you can see on panel 2. And I also got the chance to participate in the International Center for Theoretical Astrophysics summer school. so which helped me in refining my skills, honing my skills a bit more. And now I was also looking forward to connect to a wider community of people doing astrophysics, which this summer school and which doing this master's actually provided me. So after having all this practical experience of doing the real astrophysics, doing the real astrophysics research projects, I was very sure that this is something that I would want to do professionally in my future as well. And that's what led me to doing my PhD here in the University of Surrey. So I joined here in Feb 2024. It's been a couple of years almost. So in the first panel, you can see that this is our very small but wonderful astrophysics group, and behind them you can see that this is our university telescope that we use quite a lot. I use quite a lot as well, it with the students to do different kinds of astronomical observations and stuff. And here, then I started working on the project of exploring very small galaxies in the universe, a glimpse of which you can see in the panel number 3. I'll explain it a bit more as we go along. So I joined this institute in Feb, and then I started working on simulations of these very small galaxies in the universe that I'll try to explain to you a bit now. So now we will delve into the faint edge of the universe, and we'll talk a bit about the ultra faint dwarf galaxies. So when you talk about galaxies like Milky Way, your home galaxy, a galaxy like Milky Way contains like billions and billions of stars. Uh, but this galaxy not just has stars, it has a lot of dark matter as well. And if you ask me what dark matter is, well, we scientists don't know what it really is. And when we scientists don't know what a particular thing is, we like to put the word dark in front of it. So we don't know what it looks like, we don't know how it feels, but we do see its gravitational effects. And how do we see its gravitational effects? We see its gravitational effects when we see the different materials, the different stars in the galaxy orbiting around the center of the galaxy. Because there is no other way to explain the motion of the stars in the galaxies if you take the component of dark matter outside. So dark matter kind of acts as a binding force which holds your entire galaxy together, which makes it possible for the stars to revolve around the galaxy the way we see it in the observations. So we do have this kind of lot of observational evidence for the dark matter. In terms of the observational evidence, we have the examples of the rotation curves of the galaxies, in which we have just measured, how different components of the galaxies are rotating as you go away from the center of the galaxy. So as you go away from the center of the galaxy, your velocity of the components should essentially drop, but it doesn't seem to drop, and it doesn't drop because of this dark matter. So we figure out that there is, because this velocity of the galaxy is staying constant over a really, really big radius, and that is only possible if there is an additional component of mass. We can't see that additional component of mass, and hence we call it dark matter. If we talk about the galaxies like Milky Way, it is made up of a lot of planets, it is made up of a lot of dust, it is made up of a lot of stars, and they are collectively called baryons. And these baryons, they make up only, if this cupcake you can see is your entire Milky Way, the baryons, all the stars, all the gas, all the planets that you can sum up in the galaxy, they make up of just this tiny portion of the star on your entire cupcake, which represents the Milky Way. So if you have to put it in numbers, the Milky Way contains 21 times more dark matter than the luminous matter. So entirety of that chocolate part of that cupcake is something that you cannot see, feel, touch. It is the dark matter. And all the things that you've seen, touched, and felt so far, all the planets, all the stars, all the gas, all the dust, it is just this tiny, tiny fraction of that entire cupcake. And that's why we don't know anything about the dark matter. And that's why it is very important to understand what this dark matter really is. So this the galaxies like Milky Way contain dark matter, but there are other galaxies which are very small and very faint to be seen, which contain a lot of dark matter. So I'm talking about now the ultra faint dwarf galaxies. So these galaxies are so small and so faint as per their name that when you look at it in a night sky, it it would just when you search for these galaxies in the night sky, it would look like that you're searching in a dark patch of the sky. So here, this is a beautiful image of the Atacama Desert in Chile. And here you can see that the sky is beautifully lit with all the stars. You can see the small Magellanic Cloud and large Magellanic Cloud, which are the satellite galaxies of Milky Way. You can see how bright and how fabulous they look. But then you see these dwarf galaxies, these ultra-faint dwarf galaxies that are marked called Tucana 2, this Reticulum 2, Pictorius 1, and the other dwarf galaxies which have marked. Here you can see that these galaxies, they appear to be coming from a dark patch in the sky. You can see that this galaxy, when you just look at this portion in the night sky, it looks like there is absolutely nothing in it, but these galaxies are there. That is how small and how faint they are. If the Milky Way contains like billions of stars, these galaxies, they contain thousands to 10,000 stars. That is how small and how faint they are. However, these galaxies do not lose every race. They contain a lot of dark matter as compared to the galaxies like Milky Way, with some of these dwarf galaxies containing 300 times more dark matter than the luminous matter. That means 300 times more dark matter than your stars, your gas, your dust, and the other stuff. So that's why these galaxies are very important to be understood. So if we understand how these galaxies form, how these galaxies evolve, we should be able to tell a bit more about the nature of the dark matter, considering that these galaxies contain a lot of it. So this dark matter is not just very abundant in the galaxies, it is a very it hosts a very significant portion of the universe. So everything that you have seen, touched, and felt so far, everything, the desk around you, your mobile phone, me, you, everything that you can see, it just makes up of 5% of the universe. The other 95% of the universe is something that we don't know anything about. So the dark matter makes up of approximately a quarter of the universe, the 27% that I'm trying to understand. But then there is another big fraction of dark energy, 70% of it, that even I'm not studying at this moment, but maybe that can be a topic of some of the future talks that I give when I study it. But as of now, let's focus on dark matter, which makes up of a good chunk, a quarter of the universe. So I tried to understand the dark matter by understanding the evolution of these small, ultra faint dwarf galaxies using the simulations. And I do my simulations using a software called Edge. It is a simulation suite, which means that the software is made up of different softwares into it. And the full form is Engineering Dwarfs at Galaxies Formation Edge. And it is a collaborative project between Lund University, UCL, University of Surrey, and there were other universities. There are a lot many other universities now which are part of it. So now I'll try to show you what we do in these simulations. So what we try to do is that we try to simulate the entire universe in a very, very small box, which you can see in here. And this box, as you can see right now, it is evolving with the time. So now the box was evolving from the start of the universe to the present day, and you can see that as that box is evolving, it expands, and you can see that these tiny filaments which have formed in here. So the gas has all collapsed, which has led to the formation of these teeny tiny filaments, which you can see. And all this blobs that you can see in here, they are all the galaxies. All of these teeny tiny blobs, they are galaxies. And this is how the box evolves over time. So so what I try to do is I try to simulate the ultra faint dwarf galaxies in this kind of simulation box. And if you just pause that simulation box and zoom into that void a bit more, this is what these candidate galaxies look like in simulations. So here the box has been zoomed to 10 megaparsec, and but even you can see these dwarf galaxies seems to be coming from almost nothingness, like a really really teeny tiny point somewhere in the center. So and this is, I've listed the virial mass of these like, or you can just say the mass of these galaxies, and they are called halos in our simulations. So I try to understand, once I have these halos simulated, I try to understand, how they have evolved chemically. So I try to understand it by using the data for different components of the galaxy. So we have the data for the gas, we have the data for dark matter, and this is what gas density looks like. Sorry. So here you can see the simulation evolving from the past time, that from big redshift to the present redshift of redshift 1. All this bright region that you can see is the gas with the high density, and all the faint regions is the gas with low density. And here you can actually see one of these very small ultra faint dwarf galaxies forming after a lot of collisions and a lot of kind of drama which is happening in here. Ultimately, this gas blob is gonna settle, is gonna be stable as we head more and more towards the present day of in the universe. When I talk about the present day, I talk about redshift 0. This is how we astronomers measure the distances. So higher redshift, or the higher Z number, means that you are looking at very, very old times in the universe, and the redshift of 0 means that you are looking at the present day. So I have the data for the gas density, how the gas behaves, how the gas evolves. And then, oops, and then I also have the data for the stars, which I'm trying to make it work. So here you can see in the simulation of the stars, because these galaxies, they barely contain any number of stars. Let me display it for you. So the small bright blob you can see, this is the star particle, which is, these are the different star particles which are forming in our simulations. You will see them circling around each other the way gas was doing, colliding, building up. Here you can see a merger happening very early on into the formation of this ultra faint dwarf galaxies. The stars are still swirling around and trying to settle to a stable form for the present time. And so here you can see the scale of the stars here in the simulation, right? This is essentially what is the scale of the stars. And you can see now them settling in a spherical blob as we get more and more close towards the present day. Now, the good thing with simulations is that although we cannot see dark matter in the real life, we can actually see it in the simulations. So we have also simulated what dark matter might actually look like. So this is the simulation of the dark matter from the past to the present of the same galaxy that you saw of the that you saw before. So here you can see these are the different blobs of dark matter which you can see merging with each other and flying past against each other. The bright regions are the ones which have high density as compared to the faint regions which have low density. And here you can see, as you saw in the gas movie as well, there are different mergers which are happening, different things which are flying by, different subhalos which you can see in here, like the halo inside main halo. And here, notice the scale of the dark matter as compared to the scale of stars that you noticed in the previous slide. Here, you can see how big the dark matter, the region that the dark matter is occupying, as compared to the region that the stars occupied in this movie, which we saw. So here we saw the stars occupied like very less of a regime, very low spatial scale as compared to the dark matter, which actually which occupied a really big area. Yeah, I'm sure you guys saw that. So I'm just gonna go past it. So this proves actually that dark matter is very that our simulations are first off right, and the dark matter is actually really abundant in these galaxies, and it occupies like really big portion in the spatial scale as compared to your stars. So what I do is that I take these simulations, I take the data of these galaxies from the simulations, and then I compare whatever I learn from the simulation in terms of the observational trends to the observations. So taking the data from the simulations, then I compare it with the observations through the Hubble Space Telescope, and now also with the James Webb Space Telescope. Then I try to find out what are the observables which are most sensitive to the observation. What I mean to say is that then I try to find out what is one variable that I should observe. Is it the mass? Is it the metallicity? Is it the radius? Which observable I should observe, which is most sensitive to the dwarf galaxy and its evolution? So here you can see also a snapshot of the dark matter, the gas, and the stars in three of these dwarf galaxies, which we called halo in our simulations, halo 1445, 1459, 600, and here you can see this is how they are looking in our simulations. So comparing the data of the simulations with the observations, I can actually access which factors are most important in the galactic evolution of these small galaxies. Is it the stellar winds, the winds of the stars in these galaxies, which is impacting its evolution? Is it the supernova, or is it the radiation in the galaxies, which is impacting its evolution? And once I understand about the galaxy formation models of these very small galaxies, it means that I understand a bit more about working of the dark matter as well, which means that I can put my understanding of the dark matter into my cosmological equations, and I can also help in constraining the cosmological models. So this is where it leads to in a really big picture. So in the dance of the universe, the smallest entities are not useless at all. They play the greatest role, actually. So this was one part of my project. And then in the later part of my project, I got into an internship here with a company called Surrey Nanosystems. You must have heard about the paint called Vanta Black, right? So these are the people who manufacture this paint, and they had this wonderful paint out, really black paint called Vanta Black. And we as an astronomers, we were at the forefront of witnessing this problem of light pollution due to satellites. So, witnessing this problem of light pollution of the satellite, what it means is that here you can see in this image, it is a time-lapse image which shows the passage of Starlink satellite through a telescope's field of view at an observatory in Chile in November. So it was taken back in November 2019. And here you can see with the Starlink, they are creating a lot of these white streaks in your telescope images. And these streaks are not nice for the astronomers because it leads to a lot of loss of data at all of these points at which the streaks are there. So that was November 2019. But if you take the same image right now, the situation will be a lot more worse in a sense that now approximately 70,000 artificial satellites are there in orbit. And you can see when these 70,000 things are there in different kinds of orbits in the night sky, it becomes very difficult to keep the night sky as pristine as possible, so that when you're capturing the image of the night sky, you're not just seeing these bright streaks and losing all the astronomical data. So we were witnessing this problem, and that company has made that wonderful product. So we thought that it would be really wonderful if we can join our forces together for the sake of this internship, and we can um, and together do something with this paint to prevent and mitigate the problem of light pollution due to artificial satellites. So there then so in the bottom panel, you can see that there I have worked with this paint called Vanta Black, which you can see I'm holding in this image in here. So this is like the blackest of the black paint ever, and it has reflectance of approximately 2%. So all the light that gets onto it gets absorbed, and only 2% of the light gets reflected back. So that's how dark that paint is. And now what we are trying to do is we are trying to take this paint and we are trying to paint it on one of these model satellites called Jovian 1. And so we are trying to paint one of, so it is a 6 unit CubeSat, and we're trying to paint one of the faces of this CubeSat with this Vanta Black paint. And then we're trying to see how the brightness of the satellite is getting impacted because of this paint. And our mission is to just, paint the satellites black so that they do not impact and do not create these big streaks that we see in the optical images of the satellites. So this project has got a lot of attention because of Elon Musk's name, and also it is kind of very popular and very poppy sounding project with Vanta Black and other stuff. So it has got a lot of attention. It has got a lot of attention with BBC. Here you can see my supervisor Noelia and me standing with the satellite in here. And we also got featured on like numerous other articles in relation to this project. So as of now, I'm trying to draft a paper for this project on based off my latest findings. So in one portion of my studies, I'm trying to study these dwarf galaxies and trying to understand the working of the dark matter, the working of the universe. And the second portion of my project, I'm trying to kind of protect these dwarf galaxies, because you already saw how small and how faint they are, and they would absolutely be lost by these kind of streaks, which will be there in future if the problem is not solved. So I'm trying to study these dwarf galaxies, and also somewhat trying to protect it as an astronomer as at the same time. So now, after all of this, I would also like to tell you a bit about how you can explore the astronomy at your own pace, at your own time, like starting right now. And I'm sure quite a lot of people will already be aware of it, because you're already a part of this wonderful citizen science group. You're part of the Propagation Institute. So you are already doing really, really great as to maybe even what I was doing when I was your age. So you guys are already very much on the right track for pursuing astronomy. So first of all, when we are um, trying to answer what is the cookbook to for me to excel in astronomy, we should try asking ourselves the question: why we should study astronomy really? Like, why should we care about studying dark matter? It is not going to impact like any of my generations possibly or anything, right? Why should we care about the galaxies that are so far away? Why should we care about astronomy as a whole? Dude, I actually found myself thinking about that question quite a lot, because when I started studying this subject, it started more as a passion and as a love for the subject. And once you are passionate enough for a thing, or you have love for certain thing, you don't try to see the reasoning behind it as to why you want to do it. You just do it because you like doing it. But then I found myself coming back to the question again and again as to what what does astronomy add into society as a whole? So there are a lot of different fields that you can pursue. You can be an engineer, you can be a computer scientist, and other. You can be a plethora of different things. So what does an engineer do? For example, an engineer works on the problems which are with the materials present here on Earth. So they work on trying to make your life better in a sense. They would fix things for you, they would build things for you, they would make the bridges, they would make your smartphones. Being a computer scientist now, now with the computer scientists, they would take care of your data and how you're using it every day, your shopping apps and everything. So that is all needed to lead a very comfortable, very beautiful life. But we also need someone who has the courage of shining the light in dark room and trying to see what is there in the dark room. So I think this is where astronomers step in. What astronomers do is that they explore the entirety of the universe as a whole. So we are not I mean, there is another field of astronomy where you actually, work with mechanical parts like you do with JWS. So it is really wide as well. But at the core and at the basic of it, we astronomers, we don't have the end product in our minds already that, this will be the result of me studying dark matter, for example. But we are courageous enough to shine a light into a very dark room that is the universe. So it is the astronomer who first enters into this dark room to explore the universe, and they shine the light on each and every portion of the room. Because, as an engineer, it is very important understand um, understand, how the things around you really function. But then you also need to have a look and a purview of your room, right? When you're walking into the dark room, sure, you'll find some tools that are useful for you, but that is not the room as a whole. The room is like, if we talk about the fractions, another 95% of the stuff that we don't really know about dark matter, dark energy, and we barely even know about all the visible matter in the universe. So that is the role of an astronomer. They shine the light into the dark room and they try to find different things. Sometimes you find the things like when you go into a very dark room, you find the things like, oh, that is a dustbin. I don't know what to do with it right now because I don't have any trash, but maybe I can use it in future. Oh, that is a desk. Oh, that is my carpet, and all these different kinds of stuff. So that is the duty of an astronomer, to explore the things at the first hand. And then when an astronomer explores the things and when they analyze the things, that's when, the other people, other stream of the society, like engineers, then come into place, and other people, the computer scientists, can come into place, and then they can take our understanding of that particular object, for example, like dark matter or the visible matter, and then they can develop onto understanding that material like carbon nanotubes a bit more, or the diamond a bit more, and things like that. But we do need someone to take that first step, to be courageous, to shine the light into the dark room. And that's why I think we should definitely study astronomy. Not only this, it helps us in understanding our place in the universe. So in the image here, you can see this beautiful image of the Earth as being captured from Voyager 1 spacecraft as it exited the solar system in 1919. And here you can see how small and how faint we are appearing as compared to the vastness of the universe. So because we humankind, sometimes we boast a lot about our existence as well. So astronomy with its wide scale sometimes puts you back at your place. And there you understand your place in the universe, and everything that you are fighting on, everything that you love, hate, all the borders, all the controversies, they are there in just very teeny tiny dot in the universe that I don't think the universe is even aware of. And then it is also, so that is the one part, to understand your place in the universe. And then the other part is to unravel the mysteries of the things that you find in your room, unravel the mystery of black holes, the dark matters, because this is like 95% of the room that you don't understand what to do with. So we really need people, we really need someone who can work on understanding these things, working on the simulations and observations for those things. So that's why also we should study astronomy. Now, would also like to give you some use cases of astronomy as to, where astronomy came before it started the things, and how these the knowledge that you gain with that we have gained with the astronomy, it has been inculcated into our daily lives. So the first example is your GPS. So your GPS works on the field equations, the fundamental field equations that Einstein has laid. So we need to take the effects of time dilation, of the length contraction, and all the general relativity theory of Einstein, all of that into account um, while building a GPS. So, which means that when you're ordering your pizza, you're getting an Uber, you're just using your GPS to, come to, for example, Propagation Institute sometime for any lecture or anything. You are relying on the basic equations that Einstein had built at that time, which have been incorporated now into our satellites to make the GPS. Without Einstein's equations, our GPS will be off by like meters and hundreds of meters. So that's where Einstein's equations. If you just tell someone to look at it, they would say that where are you actually using it? It is not really being in use, but yes, it is being in used in right in GPSs, in your phones, in your smartphones. And then the other example is with the radio telescope. So with the radio telescope, it was somewhere in 1900s that the scientists were trying to make the ways to refine the images with the radio telescope. And now these ways of refining the images, they are now being used in your wireless LAN network. So your Wi-Fi connectivity and all the other stuff, it uses the principle of radio astronomy. So this ties up to what to exactly what I said, right? So astronomy is someone who tries to explore the universe and tries to see what is there and tries to analyze it. And then other people come, engineers, computer scientists, and other people occupations come, and they try to make it our knowledge into something that can be used in our evolution, that can be used in making our lives a bit better. The other example is with this Martian rover that you can see in here. So it has that very small instrument in here, which is SAM inlets, which is called SAM inlets. And here, what it does is that it takes the Martian soil, it puts it inside this, and it analyzes the components of the Martian soil as to how much oxygen the soil has, how much silica it has, and other things. That same technology is now being used in the UK border in these chromatographs, this box that you see, in order to analyze any explosives or any drugs that a person might be carrying through the border. So this is also one of the use cases of astronomy. The one of the software imaging techniques that we use for satellite imaging and analyzing the satellite data, they are now being used also in biology to analyze the Alzheimer's disease and to analyze the brain patterns of the patients suffering with Alzheimer's. So this pattern mapping technique is also being used in here. So now you see, there are different ways the astronomy actually circles back and provides you with a way of serving the people as well. So so I'll now give you some of the great YouTube channels and other resources that I started with when I was doing astronomy. I was doing astronomy back then in like 2018, 2021. I'm sure there are other great channels which will be available, but these channels, they still stand like really, really strong. So first is the Crash Course by Astronomy. If you just want to, have a look and see if you're really interested into pursuing astronomy, this is the channel to go to. It has engaging, fun, short videos, and it's like a crash course. It will get you through the explanation of one particular thing in like 15, 20 minutes, not more than that. Then, if you are interested in and in being updated with the latest discoveries in the space science, I would recommend this channel called SciShow Space, and it updates you with everything. And if you realize after all of this that it is something that I really want to do, and I want to dive deeper into Einstein's equations and expansion of space, dark matter, how the universe came into being and everything, I would highly recommend this channel called PBS Space Time. And it has longer videos, deeper but not very long, like 15-minute-ish videos. But these videos are very rigorous in the sense as they have very deep dives into the astronomy concepts with the mind of a physicist. So if you want to do it professionally into your future, I would highly recommend PBS Space Time. Then I would highly recommend starting to read some books. They don't have to be very rigorous, definitely not at this stage, especially when you are in your undergrad. And so, because now is the time to build like the fundamental physics concepts. But still, if you want to start with reading some astronomy books, I would recommend Neil deGrasse Tyson's book for astrophysics for people in hurry. It covers astronomical concepts, almost all of it in small details without much equations, without any equations basically at all. And we have all seen Neil deGrasse Tyson talk. He talks like fabulously, so you can see a glimpse of that in this book as well. And then if you're just interested a bit into, learning the physics part of astrophysics, I would highly recommend Richard Feynman's Six Easy Pieces. So it is not very much focused on astronomy, but it is focused on learning the physics that will be used in astronomy. Feynman, he was a great physicist. Please Google him after the session. So he covers the concepts like electromagnetism and other stuff, like six elements of the physics, and in a very easy, very understanding way. So that book really helped in me understanding physics a bit better as well. If you realize that you want to just see what astronomy offers as a subject, brief history of time is like one bible book which is there. It'll explain you everything as it says, from big bangs to black holes, with written by great mind Stephen Hawking, and it is really beautiful book, again without any equations whatsoever. However, I would recommend, if you want to dive into the equations and if you want to learn, how the thermodynamically the stars function and everything, this is the book, Gravity from Ground Up, and this is the book I used a lot in making my blogs as well. So it is like a textbook for astronomy. So, but it has all the equations, and it covers traditionally the concepts from birth of stars, the cosmic microwave background, about the universe, a bit about the dark matter, and things like that. So you have a range of books to go through, to see it, to cater your interest into physics or into astrophysics. I would say it is always good to be updated with the latest discoveries of what is happening around the world, and these are some of the websites which I have listed, and which I have listed that I myself use to keep myself updated of whatever is happening latest in terms of various launches and etc. In science and in astrophysics in general. Then I would also recommend you to follow any of your favorite science communicators, because science communicators, I think, are the people who will actually tell you and keep you updated with the reality of the field. In a sense, they are the people you can actually go and talk to about your career advice. And you can read, for example, I do write blogs, you can read their blogs and you can follow their journey, and you can actually see what is happening in the real time. So I do quite a lot of it on my Instagram channel, which you can follow, and on my blogging site, which again is completely free. And there is the scanning link for my Instagram channel in it, and I'll share my slides afterwards so you can use it when if you wanna see it in a bit more detail afterwards. And then participating in citizen science project really helped me a lot. It really helped me in defining my profile when I was applying for my master's specifically. And these I'm sure you guys must be already aware of a lot of these citizen science projects, but just in case, I've listed this different websites that I have personally gone to and the projects that I have participated into for doing citizen science, and it is always very wonderful. Citizen science is actually the one way in which you can get involved into doing real science with astronomers at this time. So I would highly recommend, if you decide that it is something that you really want to do, I would highly recommend taking some time from off your day, 15-20 minutes, and just doing your citizen science projects. As I've seen like great students who have discovered asteroids, who have discovered comets, and who have gotten their names into the papers, into the scientific papers, and very early into their career stages, just being a part of the citizen science project. So I would highly recommend these, as they're like games, they're fun to do, they don't take much time of your day, and they highly add up to your CV. And with this, I would like to end the session, as this was all about my journey as to what I am doing, where I come from, and different resources that you can pursue. And I would be very happy to take any questions that you have.
That was a wonderful session, Astha.
Thank you.
Uh, I'm Amoli. I'm also a part of Propagation. I was late today in joining. Uh, yeah, it was really good, and
Thank you so much.
I think so. You started your astronomy inclination from the launches we saw from ISRO, the Mars
Yeah,
orbiter mission, and all that. Even I was one of the person who really got in touch with people during the Mars orbiter mission, and then my journey of astronomy really started. Although I am not into the technical part or the academic part of astronomy, but yes, I am doing my part of astronomy,
great.
whatever I could do. So we start with the questions if you are
Yeah.
ready to answer. Yeah. Frederick is asking, how can we harness cosmic wave resonance in the outer space?
That unfortunately is not within my field of regime, but I would definitely like to have a bit of look into it. But yeah, I'm sorry, that is not within my regime of understanding. It is just very limited of what we understand about the universe. But that's a very interesting question, and I would have a look into that. Thank you for your
Definitely. Okay. And then Huda is asking, is viral mass the mass calculated using the viral equation?
yeah, exactly. It is the mass calculated using the virial equations. I would have it somewhat up my this board as well, which I keep scribbling onto. But yeah, definitely it is the mass that you calculate using your virial equation. It is like V square R upon G, the gravitational coefficient. Yeah.
Okay. Then again, he is asking, how big of a research gap is present in the field of galactic astronomy?
Oh, definitely there is a big gap, and the gap. When you talk about the gap, you also need to specify in a sense, what is the regime that you're talking about, because astronomy now it has evolved a lot more as well. And when you talk about the galactic physics, it is some one part. I'm tackling like one part of the physics, like with the dwarf galaxies. Then there is another part of the galactic physics which deals with big galaxies like Milky Way, Andromeda, and there are other questions which are needed to be answered there. So I would say that right now we are at the regime where we have cutting edge technology at the hand, and we have actually the resources, like we have propagation channel, and we have other people and citizen science astronomy group. We have all these kind of groups and people to help us. So I would say that I actually now is the time to address all of these questions. And today, I've been talking about, like, right now I've seen a lot of the a lot like this, especially in this decade, I've seen a lot of the traditional problems like core problem and the group of satellites problem. These have been like really standing. You can Google these names later, but these were the really standing problems in the field of astrophysics. But I've seen them being solved within this decade. So I think that this decade is the one which is working towards actually providing the solutions to really, really big problems. So I think we are really at the high time. And the gap, yeah, there's a lot of gap. As I said, there 95% there is gap. We don't really know about it.
Harshita is asking, how to approach for internship in this field. She is
Uh,
a CSE third year student and she wants to go ahead in this field. She needs some guidance.
So I would recommend talking to seeing what are the resources there in your institution. First of all, this is what I did. So I did my bachelor's from Delhi University, but there was no research program which was available at the time. So I tried talking to my professor. If he knows he's aware of any collaborations that I can be a part of, or I can do an unofficial research project under him. So there were no collaborations at that time, but I was able to do some unofficial research project under him, and that's how I got into sort of internship in a sense. But I would recommend highly talking to, seeing what is there in your institute, talking to your supervisors, and as they would really be aware of the current status of the field. And if you really want to do some courses, there are a lot of courses available on Coursera and other platforms which you can actually do, and get the certification from until you and get, any internship as in. And at this stage, I would highly recommend also participating in summer schools, as your these kind of summer schools are your internship in a sense. Yeah.
Okay. One of the members of the propagation is asking that is there any way we merge nanotechnology along with astronomy? And if we could, how could that be useful in your research and other areas of astronomy?
So in a sense, I'm already merging these two fields in my study, where I'm using the paint, which is purely made with nanotechnology, to paint my satellites black, and to prevent the dark night sky from being too bright. So in a sense, I'm merging all these two fields. Um, and that is already there, it is already impacting my work in a sense. But if you talk about the scales, of the physics as well, the physics at the nanoscale definitely needs to merge with the physics at the big scales as well. So physics at the particle level, there is a huge, I mean, there are a lot of similarities between the physics at the particle scales and the physics at really big, black hole level scale. But these two scales, they need to be definitely merged as well. And I think with the latest missions which are coming up, I can definitely see people understanding a bit more about the black holes, dark matter, different galaxies, to be able to merge these two fields together.
Yeah. Even I would like to ask you one thing, Astha.
Mhm.
See, you just mentioned about the black paint, which you are
Mhm.
trying to put on a CubeSat and send it and just
Yeah.
see what the result would be. So
Yeah.
don't you think that the satellites right now, they are causing hindrance? They are causing hindrance in the data which we are receiving. Similarly, will that the although we are covering the CubeSat with the black paint, but still when the satellite is passing through that area, I think so we won't be able to receive that data which we are trying to, because it will be hindered upon. Don't you
So
think?
the paint is gonna be very, very so first of all, the paint is not gonna be applied, I think, to each and every part of the satellite. The paint is gonna be applied to, so the satellite, it can have a lot of, so satellite generally has a chassis, that is the body of the satellite, and the solar arrays. So we can see, we will, of course, the paint is not gonna be applied to the area which is there for transmitting the information, but the rest of the part of the satellite is the one in which the paint can be applied. So we are trying to, work towards that kind of solution, rather than, I mean, painting just everything black, I think is not the very right idea in a sense. It is about painting the brightest of the parts, like the brightest of the, the outer body of the satellite, and all these things, uh, all
But
these
will it
things.
really? But will it really solve the purpose? Like the purpose was that we should receive the data without any kind of hindrance.
Yeah, definitely.
It is only due to the presence of so many satellites in the near Earth orbit that we are receiving the hindered data. So, don't you think that the telescopes which we are sending out in the space are much more useful than the data which we are getting directly from the Earth,
So there are
from the
there are
Earth's
different
telescopes?
there are different regimes to this problem as well. We have great telescopes here at Earth as well. So Earth tackles your radio regime, and it tackles your visual regime to great extent. Even right now, we have great observatories, which work. So observation on Earth is still really, really very much needed. The ground-based telescopes, they still work on, they're really big, they're really functional things, and they really work towards, analyzing the data, which reads really, really long exposure. An example of it is going to be the Vera Rubin telescope. So it is going to be based in Chile, and in that telescope, it is all going to be ground based in a sense, and it would It is essentially trying to unveil the nature of dark matter using these dwarf galaxies, and it is going to take really, really long exposures of our night sky. When you take the images which have really, really long exposures, like of of quite a minute, of an hour, you can see these bright streaks corrupting your data. And when we try to analyze the data with these bright corrupted images, of course we do have the machinery to, just get the streaks out and everything. But that doesn't help us in the, because these streaks are so bright, the impact of this brightness, it extends like very much beyond the single line as well. So that corrupts like a lot of our data. But when you paint the satellite black, essentially it is only the satellite passing through, and it is not gonna impact the brightness, and it is not gonna raise the exposure of the image really that much, so that it is completely like rendered useless in a sense.
Right, right,
Yeah.
right.
Yeah.
Thank you. Thank you. So the next question is, do we need to learn simulation? If so, where and what we have to learn?
That depends on the stage you are at. I'm assuming if you're in the school or in the university, just learn the basics of programming, just the basics of programming, no simulations or anything at this point. The simulations that I got my hands and I'm working on, they're really, really big softwares, and you get to be working with them as a part of an institution or as a part of a research group. So don't worry about it at all. I mean, no need to worry about anything, but if you want to really work on anything, just work on understanding the basics of programming, and the basics of programming in terms of astrophysics. You can work on tutorials online to see, how can I formulate the Kepler's equation or the virial radius equation in my Python code and things like that. So just try working on your computer basics at this point, and they will really uh, help you with your experience when you are finally translating it into simulations, because there are endless number of simulations which are there, but the core of them is just basic computer programming. So it is very important to get hands on it first.
Mridul Singh is asking that is astrophysics a financially stable passion outside India?
Mm-hmm,
Hopefully, in the coming year, he'll be pursuing his BS or MS in physics major
mm-hmm.
as an active member in astrophysics. He is also interested in knowing what skills, qualities, and qualifications will give him an upper hand in astrophysics.
So talking about the earning aspect of the things, it is not gonna be very fancy in a sense that you're gonna get out of your Ferrari every day. It is a wonderful job, but in terms of the pay scale, it stands more or less like your any other regular job, like for example, like a data analyst and thing like that. So uh, the job within astrophysics, how it really, when you actually start earning is, the first time you actually start earning is when you are a PhD student. So you will start to earn very, very early in your career stage, like when you are just 24, 23 going on. But the pay scale is decent. I wouldn't say it's like extremely rich, but the pay scale is definitely very decent. And especially, I think back home they have increased the pay scale now for PhDs to go up to like 60, 70,000, which is quite a good range to start with. But then you need to ask yourself if this is the range that you want to continue in uh, in all the 3 years that you are in. And even that is the same for outside. Even our stipend, whatever we earn, is dependent on the institution we get funded on. So it ranges to different things like 2000 to 1500 and things like that. And and it increases if the inflation is there. So I mean, with the prices, I would say that it is as good as any decent job that you would do. So it is not very exceptional in the sense, but I think doing a career in academics and in physics, it also like you give like gives you a freedom of doing something that you really like and getting paid for it. So it is like do it researching about dark matter, researching about the universe, you really like it and you are getting paid for doing your own research in a sense. So I think that is one of the perks that comes with it. And depending on the lab you join, generally, with PhD, you work on your own ideas. You're kind of your own boss in a sense. You work on your own ideas, refining your own ideas with your supervisor and other people. So, and it is kind of it is sometimes very flexible as well. So these kind of things also come as perks into the image. So I would say that just judging it into by just the income wouldn't be very fair. You need to see what are the different factors that are coming into it in addition to the income, and then you need to see if it is really something for you, it is really something that you would want to do in your life, and then take a decision accordingly. And you what was the second part of the question that was asked?
Uh,
um,
he he is interested in knowing what skills, qualities, qualifications will give him a upper hand in
um,
doing astrophysics.
I would say, whatever I listed right now, participating into citizen science projects and everything, participate in citizen science projects, read books, try getting into summer schools, try learning the basics of programming and stuff. It will really, really, just these basic things, if you do, it will really, really take you a long way, along with, doing your basic courses in maths and physics. It is just like very simple, not very complicated at all. Yeah.
Yeah, so the next question is how the data is fed into the simulations that you showed are determined, ma'am.
So in our simulations, the data is fed in terms of the variables and what we know about the universe already. So of course, our understanding of the universe is not perfect, but there is something that we are quite sure of. And the one thing is the cosmic microwave background. And it is the oldest image of the universe in a sense. So it is like the oldest image of all of us, the oldest picture, the first light of the universe. So we were able to capture that first light of the universe, and we were trying, and we know, we analyzed it quite well to know that dark matter is 27% of the universe, the dark energy is 68% of the universe, the visible matter is 5%. We have the basic equations of the Newtonian laws and the Einstein's equations at our hand. So these when you talk about the data from the missions, this is how, like the data from the cosmic microwave background and etc. This is how it goes into our simulations. So our simulation takes latest of our understanding of the universe using different astronomical surveys, using different data, and then it tries to simulate one of these dwarf galaxies or tries to simulate the universe as a whole, and then we then compare it with the real world observations, and then we can make out the difference in a sense, and we can see, oh, this is our understanding and this is what we get out of understanding, but this is what observations are telling us. So this is the, oh, this must be the missing component in a sense. So essentially this is how we do it.
Right, right. I would also ask some of the participants to ask the questions directly. The first question, Sheikh Sami. Sheikh Sami, can you just unmute yourself and please ask the question?
Yeah, sure. So, ma'am, I'm a high school, not a high school student. I just recently passed at the 12th grade. So, I'm since my childhood, I'm interested in this astronomy or something. Although I didn't know even the word, but yeah, now I know. And I'm from actually Bangladesh, not from India, and I I have done some extracurriculars in this field, and I'm currently doing community works like volunteering for outreach and
Mhm.
all. But in our country there's no university that provides astronomy or astrophysics, and I'm more interested in the theoretical part, like cosmology or something, not
Mhm.
in the observational part that much. But yeah, I also outreach for the observations as well. I want to know that I want to apply actually abroad for my undergraduate program. So if you provide any guidelines or suggestions, because without scholarships, I don't think I can make it. Yeah, I need some suggestions and guidelines.
It's okay to be there where you are, and you have explored your interest and identified your interest, and you're very sure of what you want to pursue. So I think you're very much at a really good stage right now as well. And if you want to pursue it in future, you need to first of all, do your year 12 with good grades in physics and maths. That is like the basic need. And then I would say the you can do it the way and the way I did it, and the way most people also do it. You can start with doing a basic course in physics, basic course in physics from any of the good institutions. If not in Bangladesh, you can apply to institutions here in India as well. To do it, institutions all around the world. I think the basics in physics are like really, really needed in a sense to do astrophysics. So you can do like a bachelor's in physics, and doing your bachelor's in physics, learn a bit more about astronomy. At this stage, you can participate in, quite a lot of summer schools, try to gain a lot of some certifications with Coursera and other platforms which are there to learn about astronomy and just try to understand physics a bit more. And in terms of the scholarship, when you will be applying either for your bachelor's program or for your master's program, you can just Google different scholarships which will be available for your own interest. There are a lot of scholarships which are available to give you the financial aid. Explaining your situation, and also the aid based on your nationality. It's all just one click away. So try googling those opportunities, and if anything interests you in a sense to pursue your studies abroad so that they can fund your studies. But I think as of right now, you don't need to worry about it. You're already doing very great as just passing your year 10. You will still have year 12 to go. So I would say right now focus on that. Try getting into a good physics course. And generally, like if you go for a physics course here in India, I don't think it is very expensive that in the universities like Delhi University and stuff. But even if you want at that time, I think you can still apply for the financial aid. I've seen a lot of my friends apply for it, and even I applied for it one point. I didn't get it though. But you can even apply for the aids in the university while you're doing the physics course. And once you have done the course, when you're doing the masters, essentially everyone applies for scholarships, everyone applies for fundings. There are different plethora of funds which you can apply for, which are available. So don't worry about it all. Right now, you're very much on the right track, I would say.
Okay, ma'am. I have passed the 12th grade. So
Oh,
yeah,
you passed
my
your 12th grade. Oh,
yeah,
okay. Sorry,
and
I just thought.
I'm a little worried because my physics grade is okay. It's We have a grade system of GPA 5. So my total grade is GPA 5 in both SSC and HSC. But in my HSC, I have gotten A in my higher mathematics. So I'm worried about this because I have A plus in physics, but A in higher maths. And I want to know that
It sounds
what are
good.
is there any scholarships in India I can approach for, or something?
Regarding the Indian scholarship, I'm not aware of the specific programs which are happening like right now, as I did it quite like some time ago. But I can,
I think so. For that, she can go through the net and
yeah, yeah.
search for herself. And even if you need some kind of help, you can definitely connect with us. I think so. That would be better,
Yeah,
right?
they're like Commonwealth scholarship and other scholarships which are there.
Yeah.
And don't worry about your grades at all. I mean, when you're doing your PhD in your masters, it is just your understanding the people look at. and not really your grades quite at a lot of times. So just try to work with the best with what you have, and I'm sure you'll be able to get it. Grades is definitely not everything here in astrophysics. So you'll be fine. You'll be fine. I'm talking at this stage of my career, so you'll be fine. Yeah, yeah.
Okay,
Okay,
so
ma'am.
we'll
Thank
take the
you.
next question from Neelam. Neelam, can you please switch on your camera? Participants, kindly switch on the camera so that we are able to make out who is speaking to us.
Okay, okay. Okay,
Thank you.
yeah. Hi, Astha. Actually, yeah, the session was really great. And actually, I wanted to ask that, yeah, the about the project, means like your project. It's recently when I like saw the news about some like 3I Atlas, like the comet. So when I saw the Earth's surroundings or the environment, it was really clustered. So seeing that did make me realize that yes, there is a lot of light pollution, and like how many satellites were circling around and consistently were there. So that's a very good thing, like to repair the damage that we can done. And the second thing that like currently I'm doing, I do have interest, like a top of interest in this astrophysics itself, but I'm doing a project in chemical graph theory right now due to uh,
Mhm.
some something coming up. So, is there any way that I could go from there to this, or do I have to just see like my PhD in directly astrophysics or this? I have done everything in my studies in maths.
So at which stage of career are you in? Are you in your master's or bachelor's?
I have done my master's. I'm doing a project which is like supposed to be converted into a
Ah, okay,
PhD.
okay. Okay. So I would say for an astrophysics PhD, I would say you can still see astrophysics is a really big field. So it is not just working with the data and the telescopes all the time. We do work with quite a lot of materials when it comes to analyzing like the asteroid data, and all the other chemical data that you might get from like the Martian soil and other stuff. So I think you need to search for how you can convince the people in terms of your transferable skills from this project to astrophysics. So you need to think about it. When you're giving an interview or you're writing a cover letter for your PhD position, you need to find the positions for which you can actually write that these are the skills that I have. I know how to analyze the data. I know, how to use these kind of instruments. Maybe there are different kinds of instruments that you might be using, or different ways of analyzing the data that you might be using. So you can tell them that this is what is the skill that I have, and this is how it can be transferred into maybe studying Martian soil or studying this. So I would think that you need to see the PhD projects which are a bit in line in a sense of your transferable skills with the current project that you are doing.
Okay, okay,
Yeah.
okay. Yeah, that's thank you.
Okay, so the next question, Tanish, can you please go ahead with your question and kindly switch on your camera? Tanish? Okay. Yeah, he's there. Tanish, kindly switch on your camera, please.
Yes, ma'am. Hello, ma'am. Ma'am.
Yeah.
Uh, by the way,
Tanish, we are not audible.
Ma'am, I think he is facing some network issues.
Yeah,
He,
I suppose.
he has put his questions in the chat box as well, ma'am. Okay, but yeah, just go for the another one, like I spoke.
Yeah,
hello, ma'am. Hello, ma'am. Am I audible?
yeah, you are.
Uh, by the way, my question is related to my career related. I am preparing for uh, 11th standard for JE. I am interested to participate in astrophysics competition Olympiad. Uh, so, so which book should I prepare for it?
Um, I did not myself participate into an Olympiad, so I can't really tell you about the exact book you should use to learn to pass the Olympiad. But I would say that if you want to just start with, the basics of astrophysics, the book that I recommended, which I'll share as well, The Gravity from Ground Up, that is a really good book which tells you about the basics of astrophysics, like the stellar astrophysics and the universal astrophysics. So tells you about all of these components that you can use. But I would suggest that just try looking at the web page of the previous year questions as to what they are, and try googling just a bit more to see what books like the previous year people might have used for that particular specific Olympiad that might be useful. But for the general knowledge about astronomy, you can go to Feynman lectures, you can go to the different resources of the books that I have mentioned. But it just depends on the level of your Olympiad. If it's going to be a lot mathematical or a lot qualitative, it depends on the level of the Olympiad and the institution you are taking under and all these kind of things as well.
Okay, ma'am.
Okay, so the next question coming up from Harshil. Harshil, kindly ask your question.
Hello, am I audible?
Yeah, please switch on your camera.
I'm unable to switch on my camera at the moment because the network connectivity at my end is not that great.
Okay,
I apologize for that.
no problem.
Question is, like the observations which were there, the expansion of the universe, it should have been, the universe should have been, you know, or collapsing into itself because all the matter is present, but it was expanding. So that and similar other observations which led to the idea of dark matter and dark energy existing. Prior to this idea, there must have been some other hypotheses which were proposed. So my question is, what were those hypotheses and what led to them being discarded?
So especially regarding the dark matter, there were a lot of hypotheses which are still there and they are still being proposed. So for the dark matter, so everyone kind of agrees on the basis of the observational evidence that there is this thing called dark matter. But people don't really agree on if you need a new particle to explain it, or you can just explain it with the existing laws of physics. Is it just a play of the existing? I mean, the observations are there, but if these observations are a play of the existing laws of physics, or you need like a really new particle, a new wave or new energy to explain it. So they've in context to like the dark matter, there has been very famous theory called modified Newtonian dynamics called MOND, and that theory essentially says that dark matter as a particle is not there, and you can just explain whatever you are seeing in your observations in terms of the rotation curves of galaxies and the other stuff, just by modifying the Newtonian laws at different scales. But that theory is still there, changed different forms and everything, but that theory is still there. And but with more and more evidence coming up, like with the evidence of the bullet cluster, there was this one particular image of the bullet cluster in which there was this image of a cluster which looked like a bullet. So that was like the one portion of the cluster with all the gas and the other portion of the cluster which was like this. So analyzing this cluster and the mass distribution of that cluster actually not visually, actually helped the scientist in discarding the fact that that dark matter is something that can be explained with the modified Newtonian dynamics. So the modified Newtonian dynamics people said that dark matter, it is something, it is really not there, and you just need to modify the laws of physics to explain your observations. But that particular evidence for the bullet cluster and mapping the mass of it away from the mass of the baryons clarified the fact that dark matter is still a particle and it is still there. So, and then there are different theories of dark matter and related to WIMPs and related to axions and other stuff. But a lot of these theories are still theories. they have not been tested. There are different dark matter particle detectors around the world. So people have proposed like different nature of the dark matter interacting in dark matter, and there's the dark matter particles self interact amongst themselves, they annihilate and everything. There are weakly interacting dark matter particles. So and they have proposed like different ranges for the energy of the dark matter particle as well. So with different observations coming up, what we are trying to do is we are narrowing our options to, from a bucket to like a cup. So now we know about dark matter. First of all, that MOND is not likely to be an explanation for the dark matter. We know that the dark matter should not be very warm, because if the dark matter was very warm, you can't really collapse the structure in the universe and see it in the present day as you see it in the simulations. So the dark matter has to be cold. So this was about the dark matter and about the dark energy. The story was really wonderful as to how it was introduced. So Einstein introduced it into his equations first, but then he removed it, calling it his biggest blunder. But then later on, with the observations of Hubble, we realized that the universe is actually expanding, and that expansion of the universe now it's called dark energy. So dark energy is like a force that exists in the universe that causes, if you are baking a bread in a sense, and how that bread expands in your oven with the yeast that you put in. This is how the dark energy actually works. So with the evidence of dark energy is actually the redshift and blue shift of the galaxies, which you can see as you get the data. So
Right.
this is how we have different evidences, and this is how, with the dark energy, we first thought that it is not there. Now it is, I mean, Einstein, the brilliant mind, thought that it is a blunder, but now it is there. So, I mean, these are the different things that continue happening when you are trying to do science in a sense.
I think so. Some basics can be studied from this book, Dark Matter and Dark Energy. This is a very simple book,
Okay, ma'am.
which will explain something about the dark matter and dark energy on a very layman level. I have read this. What I do is I just read these kind of books so that I can curb my curiosity. Okay, so the next question coming up from
Ma'am,
Tejas.
actually, I had some more questions.
Okay,
It's okay.
continue, please. Harshil, yeah, continue.
Ma'am, I'm currently in my first year. I'm pursuing a BSc Honors in Physics from National Institute of Technology, Rourkela. So, and I have, since a long time, I have decided that I have to go in the field of cosmology or astrophysics. That I will decide in the way my interest develop in the future. So what's the best that I can do now? Then recently I applied for there's a workshop being organized by IOCA
Yeah.
in the month of December. So I applied in that. I'm just waiting for the result. They release a list of selected candidates. So if I'm selected in that, I would surely attend it. But apart from that, what else I can do?
Are you talking about the variable star astronomy workshop?
No, ma'am. It would start from the introductory courses and then it would scale up because it's for UGs, PGs as well as for the people pursuing masters.
Okay.
So I think you're very much aware of your interest. Again, you have applied to summer schools. Apply to as many summer schools as possible, because participating into summer school is something which will give you the pure taste of astrophysics that you should receive at this stage in the career. Definitely do the citizen science project. The people that you interact with within there, they are the academics who are actually working in the field right now in those projects that you might be interested in. So just have a one-on-one conversation with them and try to, see if there are any projects, any opportunities under them that you can undertake. And sometimes it is like just asking works out really well. It is really helpful. And I would say that, you can do a lot of side courses, as I already suggested earlier. So if nothing works out, you can always do the citizen science projects. You can always do some science courses, focus on the programming part a bit as well, in terms of, general Python programming and stuff. And if you just do these basics, I think you will be in a very good position for taking it forward as well. Yeah.
Thank you.
Okay. So Tejasvi, can we have your question, please?
Yes, yes. So it is a very nice talk, and I want to ask for the PhD in astrophysics. So let me give my brief. So the next question I can ask. So like I have completed my master's MSc in astrophysics, and then I get a chance to join at PRL for 1 year, which was the post degree course of the space and atmospheric science. So at that time, I have done the 3 years, 3 months of like research work in the Venus lightning. Like so, now I'm again back to the astrophysics. So right now, I have just to write a paper on the Cygnus black hole also, but I need a guidance. I have just for the PhD at abroad. I have applied at many good universities, but due to the some reasons of LOR is not submitted on time, my application
Oh,
has withdrawn. Like I have
oh,
just lost a good amount of money too. So
yeah.
like
So
what I
for
need to do, because I found myself that my CV is now it is strong that enough that I can apply, and due to this interdisciplinary things also I have built a very good skills, so that's not an issue. But somehow in between I'm lacking with this application and LOR thing and everything. So yes, I
I mean,
really need
I
a
think
guidance.
LOR is the first thing that you need to really, really sort, because that is like the really, if you're, even if your application is really, really strong, you need to have the LOR, because otherwise, even if your application is strong, it can get rejected for, this administrative reasons as well. And
Yes.
about the PhD rejections, like in general, don't worry at all about it. Even when I was applying for like a lot of these positions, I received a lot of rejections, like from 10 plus spaces and everything. And it is just that, there's just different things which are there. I mean, the current political situation of the world is not very comfortable as well. That is also one thing which is there. So don't take it like really, really very personally when you receive a rejection from some place. There can be different factors. It is always easier for an institution to incorporate some person who is born and brought up here as compared to getting someone from outside, especially at this time and age. So I mean, there are these factors which are there, which are different. There are a lot of these kind of factors which are definitely out of your control, to basically see where the rejection is coming from. But you need to make sure that what you do from your end should be perfect. What
Yes.
you do in your, when you put your application, when you put your CV, it should be, first of all, you need to definitely put your LOR. So you talk to the person who is giving your LOR, and if they are very busy at the particular time, try having some backups.
Yes.
Backup people to whom you can actually ask to send the LOR as well. So I think your application looks really, really strong in terms of the number of projects and extracurricular activities you have done. So don't need to worry about it. Just sort the basic things with the LOR. And I would recommend a site called findaphd.com.
Yes.
And yeah, that website is really great in terms of, finding you the funded positions which are there. And you can just apply and even contact the professors using that website. And generally, sometimes the positions are not listed there, so you would sometimes need to just Google the institutions manually, the astronomy institutions, and try to see the programs around it. Sometimes the application process is a bit straightforward, get the funding available, so you just need to apply for it and you'll get funded and you'll get paid for it. You don't need to apply for like funding externally, but sometimes you need to apply for funding with it as well. So sometimes you need to apply for a funding program and then go for a PhD position. That is also there. Sometimes when you get selected for a PhD position, you and your supervisor, you together apply for funding. So there are like different versions of this thing. So I would say, to make the things easiest for you, just try with the with the website, finding the positions which are there, and for making your application stronger, just do basic YouTube search, Google search, and on how to make my application better, how can I better excel into interview and all these kind of things. But yeah, first thing first, you need to sort out your letter of recommendation, definitely.
So
Yeah.
yeah, so second, my question is, do I really need to do the dual master degree or no? Just apply for the PhD application.
No, I think with your master's in hand, you are eligible to apply for the PhD. And your cover letter, you just need to show that these are the skill you have and how the skill can be transferred to this project that you are applying for. So the dual master, you already have a master, right? So I don't, the dual master is not needed. Yeah.
And like the recent things what are going. So what now I am seeing that people are taking those who are data analysis or they are good in the coding.
Mhm.
So
So I would say
we should
coding is
go
really
in that
important.
way also. Yeah, just build a good thing in astrophysics or
So coding is, I would say, one of the most important components, especially now in time and age of AI and everything. You definitely need to know your basics in a sense. And even if you don't know about it, don't worry. Just go through a couple crash courses to get, the basic hand of Python and other software that you might be using. But you don't need to know everything about the software that you're working on at this point. Just the basics of like Python and the other, how to make an array, how to do like different things with array, and how to read a file, these kind of things. So I would still say that data analysts, I mean, they have an upper ground in that thing, but I would still say your knowledge and your knowledge in physics that you have is going to take you longer, along with a bit of the data science. So don't worry about it. Even I didn't have it when I was doing my master's. I did learn a lot of it on the way in my project. So you're going to learn a lot of it in your way in the project, but just make sure that you just know the basics of what to start with. Yeah.
so for the India also, like they have the criteria of the examination. So now we have come so far for these things that
Uh-huh.
to cover all these subjects, it's kind of difficult.
Yeah,
So
the things have changed like quite recently as well. So I mean, it should be like that, that the schools should already give you all the necessary skills, and then you don't have to, do all these extra things at your hand. But unfortunately, with the changing times and everything, it's just that they are making the exams a lot more harder, but the education is just staying pretty much the same in basic schools and institutions. So yeah, I mean, if it is the exam, yeah, you need to see the previous year's papers and prepare accordingly for the data science part of it as well. If you want to learn a bit about like machine learning and all this kind of stuff, there's also a website called Cattle.com, and they have very interesting projects for machine learning perspective, which are even used in like the job interviews and stuff that you can have a look at for if you want to learn like machine learning part of the things. I would say that there is like a lot of things will be asked from you because of the changing times and everything, but just be confident in yourself to just start with learning and sit for the exam, sit for the interview, and you will eventually be able to do it. You won't realize it, but you will be able to get all the basics and everything. So just start with it and without getting intimidating, and that is possible. And I know it's very hard. I know it's very hard. So don't worry about it.
okay, thank you. I just want to also, if Molly ma'am can tell. Yeah, she's also.
I think so. Astha is saying the absolutely correct thing. She is. She has actually gone through the whole of the process, so she knows the best. I am not into. I haven't done the masters in science, so I cannot comment on that. I really can't.
Okay, thank you.
Okay. The next question coming up from us, Akash. Yes, Akash.
Hello, ma'am. Am I audible?
Yeah.
Okay, this is going to be a question that is totally poles apart because I am a computer science student and I'm looking forward to transition into astrophysics. Like I'm in my final year and I do hold some conditional offers, including a University of Surrey. Uh,
Mm.
my question is, how is the research ecosystem over there? Like, because I'm totally new to this field of research, and I'm not sure if research is to be carried out independently or is it to be done under the supervision of someone as such. And again, I am quite familiar with machine learning and stuff, but I'm not really good with the theoretical aspect of astrophysics. So how do I bridge this gap?
First of all, you already have, the basic skill of programming, which we need in here. And even in my department recently, a couple people who are computer scientists, actually, they joined into the PhD project. So they're now learning about the basics of astronomy and stuff, while they do have the skills of, the machine learning and other things. So don't worry about it at all. You have the right skills. See, whatever you guys do in general, you just need to show them that you have transferable skills for a particular project that they are offering. No matter what you are doing, if you can prove to yourself and you can prove to the institution that these are my transferable skills, that can be applied to this astrophysics project, you are fine to go. Coming to this university specifically, we would be very happy to have you here. And will you be coming for like masters or bachelors or PhD again? Sorry.
Uh, like for masters, I'd be considering it, and for bachelors, I have also applied for my final year project over there. So if
Uh-huh.
approved, I'd be there for my capstone as well.
I see, I see. So here in the university, they offered, I think, in the final year, a specialization. So, like your master's program, it has different modules, astronomy and physics related modules that you need to go through, like thermodynamics and special relativity and all this kind of stuff. Basic astronomy as well. So if you choose, you can pick and choose a lot of these modules, and you can build your profile around it while you have a background in computation already. So, and in the final year of your project, you will be asked to do some sort of specialization in one of the fields of astrophysics if you choose. So you'll be asked to do it either in nuclear astrophysics and in stellar astrophysics and like different projects. So here our group mostly focuses on the galactic astrophysics. So we focus on Milky Way, Andromeda observations, simulations, the tides, and a lot of latest missions like Arrakis, if you Google it, and all these kind of things. So it is mostly the people who work here are mostly like Milky Way and galaxy people, not that much cosmology if you are looking for it. But I'm sure that even in this regard, you'll be able to find a bit of grounds in on these things. But this institute is really for the galactic and also a bit of stellar astrophysics. So we do have a stellar astrophysics group. We run the star-based codes and analyze the winds of the stars and stuff. So if it is really something that is of interest to you about the galaxies and about the stars, the kind of stuff that I'm working on, um, and kind of close to that, I think this is what this institute kind of offers you. And you don't need to worry about your background just in computational astrophysics. You can always build it either externally, through, as I've been saying, through the certifications, to participating in different courses. You just need to make the people see that it is not a sudden switch that you are doing, and it is backed up by some sort of interest. So you need to have some evidence for it. Participate in the citizen science projects, read a couple books and do some particular things which you can actually put in your CV and show. I mean, you'll have the certification like from this lecture as well, so put these kind of things, and they should be sufficient enough to even get you a PhD as well. Because in my department, there are a lot of people who did not have a background in astronomy. They are learning some bits and pieces of it in here, but they do know about the computer stuff that they have done, and they do know how to translate it into the project which is being offered. So that is there. And astrophysics as a whole is a really, really big regime. So if you're really a computational person, you can work on really making the pipeline for the particular project, and that is just GitHub, and that is mostly computation stuff. So you can also pick and choose the project which you like as per your skill, which suits you. And I'm definitely sure that with the field being so vast, you'll be able to find something that interests you. And everything uses computers and computer science, data analysis, a bit of machine learning, neural networks, and things like that. So you don't need to worry about it at all.
I think so. He's already having the basic build up with him.
Yeah,
So he
yeah.
just build up on it.
Sure, I'll do that.
Okay, okay. Asa, I would also like to ask you one more thing. You just mentioned about the simulator, the edge part. What is that actually? I couldn't really make it out. Could you
So
just
it is a
explain?
simulation suite, which means that the software is built with like a different simulations into it, in a
Okay.
sense, and you combine those different simulations, and then you make this really big simulation suite called Edge. And what it basically does is that using that simulation suite, we can simulate the galaxy in a very small box, which you saw, right? We can
Oh.
simulate these dwarf galaxies, and then we can use that simulation and whatever software which is in their simulation suite to get the data from from that galaxy simulation. So I can get the data of, this is the velocity of my star particle, this is my gas temperature, this is my gas density, and things like that. So it is not open source as of now. It is, it is not publicly available, but the website is up for it, and I can share the link with you guys in here. I think the website should be up. So
Because these things really intrigue me. I really get interested in these kind of stuff.
yeah, so I have sent a link in the chat, and it is the page, and you can get a basic idea about what it really works and what are the basic results and everything.
Hello.
Yeah. Anyone speaking?
It's me, Frederick.
Yeah.
So I want to ask question because I'm based here in Nigeria, in West Africa.
Okay.
So
You may.
I want to ask, yes, I want to ask the guest speaker. So how can we expand the frontier of astrophysics in Africa here? Because over here in Africa, there's a little bit of penetration here in Africa. Is there a way, because astrophysics is a very advanced course, do you understand? And it needs a lot of how will I put it? A lot of capital to be able to set up an astrophysics center here in Africa. So how would that be possible? So that's what I'm asking. That's my question.
And so I would say that, you can start by, of course, there are big changes that are needed in terms of science policies with science minister and all these kind of things. If you really want to take it to like really political and national level, you can write to your science ministers about it and see their response on this thing. But if you really want to start with it right now, or with the things in your hand, you can start by doing things like I did. You can start by just communicating the science a bit more, like in your neighborhood, and just trying to educate the people about the existence of this field a little bit more as well, because this is how the big changes come. You really need to do the efforts at a really, really small scale, and then you will really see the people come out of it. And a lot of people will have the similar idea as well. They would really want to do this thing, but there is no resources which is available. So I would say start with thinking about what you can do for yourself as a person who has this amount of knowledge of astrophysics. As of now, you can do the citizen science projects. So once you are doing this as citizen science projects, you can set up you can just start setting up like a small WhatsApp group of like 10 people who do this particular citizen science projects 4 month every year. So you can do that. You can participate, you can organize a lot of these events called like the World Space Week and other stuff. So in which, just from YouTube, you can Google simple astrophysics experiments of the lunar, of observing like if there's an eclipse anywhere or anything like that. How you can do these kind of things. You can have a look on the internet and you can do the events like World Space Week and things like that. And then you can collaborate, I would say, with the educational institutions and just tell to them that, we want to deliver a lecture in astrophysics and it's absolutely free for students to attend. And this is how the things will, build up like really, really slowly as well. And if you want to write, you can then, with some achievements that you would have already, you can write to your local ministers, you can write to your local leaders about it, that this is what we have done. Can we have any funding for it? And things like that. But it would really need to start really small and really slow. But if you are, I mean, specifically for you, because you told that there are no opportunities available, I would be very happy to be involved and deliver more lectures or anything if it is needed for a group of people that you would collect, and guide them on to what they can do if you want to pursue astronomy as your career. So I would be very happy to assist. You can contact me on my Instagram, on my email, and all this kind of stuff. And start maybe, the blog that I write. It is very basic. Start reading that and all these kind of things. So I would be very happy to help you start anything that you would have in mind. Yeah.
Sorry, before I interject you, thank you for explaining that. I really appreciate.
Thank you.
Thank you. Thank you. Yeah. Also has a question. Propagation. Jitendra.
Ma'am, I have basically something to say to the Frederick. Frederick, just do one thing. If you need any help and if you're just trying to organize any event, we are with you. So if you need any help, Propagation Institute is with you. We are having lots of professors, lots of speakers with us. So just try to make the group, as ma'am said, Astha ma'am said, just try to like organize any events. We would be able to provide you the platform. Okay, you can just organize any event with the collaboration with the Propagation. Okay, Frederick, I think this would be the better start from our side.
Yeah, yeah. One step at a time and we are good to go.
Yeah.
Okay, so I think so we are over with the questions. And thank you, Astha, for such an insightful knowledge which you have given us through the career path and through the simulation part and everything what you do and what you are trying to deliver to the astronomy community. That's really good. That's really good. And I really appreciate your efforts from being a normal student, starting from the launches, the missions which you have been launched from ISRO, and then doing the citizen science projects, and then going to the University of Surrey and doing your PhD. That's really commendable. Thank you.
I'm really, really grateful for this path as well, and especially like to my parents who have been supportive as well. And I see my mom has joined briefly as well. Yeah, so I've been very grateful for all the support that I got with my friends, with my parents. They took me to the observational nights, and they kept the faith in me that I can actually do it. So thank you to all the people who believed in me. For that, essentially it is just a reflection of those people and all great opportunities that I got. I connected with Sovan sir, and it was really great as well, and in giving the opportunity. So it's just that all the great people that have been a part of my of the process, it's just a reflection of all those people.
Definitely. I think so. Sovan sir plays a very major part in the citizen science group, because I am also a citizen scientist and I came in contact with Sovan sir a few years back. So he has been an integral part for the citizen science projects.
Yeah, definitely.
Yeah.
Definitely.
Yeah. So over to you, Yash.
Ma'am, there is a last question by Abhishek Ras. Basically, he's having lots of noise around him, so that's why he just put his question in the chat box. Please read out those questions.
Okay, okay, I'll just do that. Yeah, Abhishek is asking, he's a first year undergrad student at DU doing his physics honors. His question is that if he wants to do masters in astrophysics in Germany, do he really need to do 4-year undergrad or 3-year undergrad would be fine?
I did
The
a
first
3-year undergrad and I got in Belgium, which is in Europe as well. So I think you should be fine. You just need to prove it to them that whatever, have some sort of, research experience, either unofficial, official. You need to show them that you're really, really interested in your application. That is the main thing. Of course, having like a research experience, a research year would really, really, it really pops up on your application, and it really makes the process smooth. But I did a 3-year bachelor's and I was able to get selected for K Leuven on basis of the citizen science project, my blog, and everything that I was doing. And so you just need to show them and provide them enough evidence that this is the skill that you have, and this is how you are actually interested in the project and you wanna do it. So it is not necessary to do it as per my experience, but it wouldn't hurt to do it as well. And if you you just still, I would still say, if you're at the States, still apply for that institutions in Germany with the experience that you have, and try to see what you can do right now to apply, what courses you can take, what courses in a sense, as I mentioned, what short courses you can take, and what all citizen science projects maybe you can put in your CV, and try to see where you can get with it. Because the market changes quite a lot as well, in terms of what the institutions want, what was the time before, what is the time now. I mean, I did my master's in 2020, 2022, 2023, things like that. So, I mean, the time has not changed much, but I would still say, go with what you have and try to make your application better at this stage. And if nothing works out in this time period, that no institution is accepting and everything, that you can, then try to have a research year or do something related to that as well.
He has a second question as well. He says, what is the basic difference between astrophysics and cosmology on the basis of their work? And what if he wants to be a cosmologist?
So the astrophysicist focuses on the galaxies, and all the astrophysicist focuses on galaxies, stars, and the physics of the astronomical stuff which is present around you. So astrophysics is something which I am doing. So all this explanation that you saw right now with the galaxies and everything, that is astrophysics. Cosmology is the study of universe as a whole. So you'll be studying not the evolution of galaxy, but the evolution of the entire universe. You'll be studying about dark energy, a bit about dark matter, but taking like another field of view in that sense. So it is, when you want to study about the universe as a whole, like the person who actually made the chart for 27% dark matter, 5% baryonic matter, 68% dark energy, a cosmologist would have been there at least to give them a sense of entire composition of the universe. So astrophysicists, we work on seeing the different stuff around us in the universe and trying to understand it. A cosmologist works on bigger picture, understanding the universe as a whole, the expansion of the universe, what will be the fate of the universe, the Big Bang, and all these kind of things.
Multiverse and all those stuff.
Multiverse and all these kind of things. So astrophysicists don't study the universe as a whole. We kind of study universe and bits in the parts that it offers.
Yeah. So basically, cosmology is the whole human body, and the astrophysics part is studying an organ in itself.
Yeah, exactly.
And his third question is, we all know mathematics is important for physics, but how deep should we go? We have seen that if someone is really good in mathematics, they do good in physics as well.
So they say that mathematics is the language of physics, which is very true as well. You would need to have mathematical background to understand, basic things, differential equations, integration, and tensors sometimes are needed as well. So, I mean, if you talk about how, yeah, tensors is like the ultimate thing. So differential equations, integration, tensors, vector equations, and all these kind of stuff. But I would say that if you're performing quite all right in your undergrad physics, that is the level you need to be at for mathematics to do anything in astrophysics. So yeah, you just need to do your undergrad physics really, really well in terms of mathematics, in terms of physics, to really give you the basic tools to do astronomy later on. Yeah.
One more question from one more participant, Mehek. She is asking, is it possible if she could do online project under your guidance?
That would be really great. That is something that I'm looking to get onto. But as of right now, as I'm doing my PhD, and I'm already working on these two projects, so I don't have the time actually to supervise really anyone, but I would be very happy to provide you any guidance if it is needed. You can just email me anytime, or best way to reach me is through my Instagram that I listed, for getting for getting answers to any questions that you might need. And I would say at this stage in the career, it would be really great if a professor from your university or someone who can be in touch with you quite often can be there to provide you the supervision that is needed for the project. But if I start anything, I would definitely, once I've finished both these projects and everything, once I start anything, I would definitely put the information up, and yeah, definitely then we can start together. Yeah.
Great, great. Nice listening to you, Astha. And I think so we come to the end of this session, the lovely session. I would request all the participants to kindly switch on the camera so that we can take a photograph.
Mm-hmm.
I hope, yeah.
Everyone taking too much time. Everyone, please turn on your camera. Other people also.
If you're in obscene positions, you do
Just
not.
turn on your camera.
Right.
All right. Thank you.
Okay. Thank you, everyone, for joining us today in this interactive session. And thank you, Astha. Really lovely hearing from you and listening from you, even learning from you. Thank you so much.
Thank you so much. I'm very grateful.
Thank you.
Thank you so much, ma'am.
Thanks so much.